So this is video 3 for chapter 3. It actually goes with the extension in the book. So if you look in the book, there's an extension after 3.2 on factoring expressions. So in this section, we're going to factor out the greatest common factor of a linear expression and then rewrite it in factored form. So our vocab for this section is really just factoring. So our first definition of factoring is to write an expression as a product of factors. Okay, so we have to remember what product means. Product means we're using multiplication, and then the factors are the things that we would multiply together to get an answer. So we'll go over lots of examples, but when we say to factor something, write it out multiplying the factors together. And then our definition too, quite simply, is going to be to pull out or divide out the greatest common factor. So when we ask you to factor an expression, we mean pull out, figure out what the GCF or the greatest common factor is, and divide it out. And then we're going to rewrite that expression in factored form. Right below our vocab, there should be a place that says GCF on your note sheet. If you need to write it down, that's the greatest common factor. So greatest obviously means largest or biggest. Common means what they share or have in common. And then factor, numbers that multiply together to give you something. So you've heard of GCF before. We use it a lot in fractions. We're going to be using it here too with linear expressions. So to factor something, we're going to have to find that largest shared factor between two things, and then we're going to divide it out, pull it out, and rewrite it. Okay, so here's some just practice finding the GCF. We're not really factoring yet. We're just going over what a GCF is again. Remember, the GCF could be your smaller number. So if you look at a pair of numbers and 2 goes into 2 and 2 goes into 10, 2 is the biggest thing that goes into both of those. 2 is your greatest common factor. Same thing here. 3 does go into 24 as well. 3 is the biggest thing that goes into both of them. 3. Okay. When you get to a little bit bigger numbers, you kind of have to know your multiplication facts. Okay, list out the factors for both of the numbers until you find the one that matches. So for example, 9, 1, 3, and 9, 27. 1, 3, 9, 27. Okay, and I noticed that they both share 9, so that's my greatest common factor. Again, it was the smaller number in this case, but I have to think about all the factors that make those numbers up and find the biggest one that they share. I'll do one more and then you're going to do the next row. 16 and 20. Okay, if you know your multiplication facts, you can probably come up with it or start listing them out. 1, 2, 4, 8, 16. Factors of 20. 1, 2, 4, 5, 10, 20. Until you find the biggest one that they share. Looks like 4. So 4 would be my GCF. Okay, so there's another row here of practice. You find the greatest common factor for these pairs of numbers. So pause and then we'll come back and check. So here's the answers I got on this one for these practice ones. So check those. And then now we're going to move on with some more on factoring. Okay. Remember, here's just a hint. You can either find the GCF in your head. If you know your multiplication facts, you can probably think of those factors in your head and find the biggest one that they share. Or if you need to, list them out. So if you feel like you're not quite sure, start listing out the factors for each of the numbers until you find one that they match or that they share. Okay, so here's some actual practice with factoring expressions. Okay, here's my expression, 24x minus 18. I've got two terms. I need to find the GCF between both of those terms. Okay, so we're going to be basically looking at the numbers, the 24 and the 18. Think of the greatest common factor for those. Let's see, 2, 4, 6, 6 goes into both of them. Okay, so this is 6 times 4 times x to give me 24x. And this is 6 times 3. And one of those is a negative to give me negative 18. Okay, so I can see that the 6 is the greatest common factor. So I'm going to pull that out. You always pull your greatest common factor out front and then what's left for each of those terms. Okay, so I can't change colors here with my pen, sorry. All right, so since I have 4x left in the first term, and then the negative and the 3 left for the second term. Okay, so I factored it and I got 6 times and then parentheses 4x minus 3. Now you can always, and I do need another color here, you can always distribute this back to check your answer. Okay, so 6 times 4x, 24x, 6 times negative 3, and that gives me my original problem, what that I started with. So I've checked it and I know it's right. Okay. All right, let's do another one. How about let's move down right below. 6x plus 27. Okay, well, factors of 6x and 27, I'm looking for the greatest common factor between those, probably 3. Okay, so let's write them both out as factors with 3. So this is 3 times 2 times x, and then 27 would be 3 times 9. Yep. So 3 is what they share. Write that out in front. Then your parentheses, and then tell me what's left in each of those terms after you've pulled out the 3. Okay, so let me change colors again. Here I have 2x for the first term and a 9 for the second term. If it's positive, put a plus sign. Okay, so to check it, let's distribute. 3 times 2x is 6x. 3 times 9 is 27, and it's a positive. And that was my original problem. So I've checked it, and I know that it's right. It works. Okay, 12z plus 40. Well, factors of 12 and 40 that they share, probably 4. Okay, so I'm going to list the factors with a 4. So 3 times 4 times z, and 10 times 4. Okay, so pull out the common factor, the 4, and then what's left in this first term, looks like I have 3 and z, and then what's left in this term would be 10, and it's positive, and that's it. And then I just need to distribute and check my answer. 4 times 3z is 12z. 4 times 10 is 40. Everything's positive. Yep, that's what my problem originally started out as, so I know I've checked it and it's right. Okay, last one that I'm going to do, and then you've got lots of practice. Okay, 21y minus 14. Okay, well, probably 7. 3 times 7 times y, and 2 times 7, a negative, and a 2, and a 7. Okay, so they share the 7. Pull that out front. The first term has 3y left over, and then the second term has a negative and a 2. Okay, distribute to check. 7 times 3y, 7 times negative 2, and I get negative 14. Cool. So before we go on and do some examples with negatives, I want you to fill in the blanks here. Here's your hints. Pay attention to the signs. Right? Pay attention to those positive and negative signs as you go. And then always check your answer by distributing. When you're done, once you get an answer and you think it's factored, distribute it back to check and make sure you get the original problem back again. That's how you check your answer. Okay, let's move over to this other column. Now you'll notice that I have negatives in front. Okay, still not a big deal. You're still going to think about the GCF and find the greatest common factor, but now you're going to have a few extra negatives. Okay, so when I look at a greatest common factor for negative 3x plus 12, this would be a negative and a 3 and an x, and this would be a 3 and a 4. Okay, now when this front number starts with a negative, you're going to pull that out as the greatest common factor. So negative 3 is going to be my greatest common factor. That means I've pulled it out of both of them. Okay, the first term just has this x left, and the second term has a 4. But think about your signs, right? This is what we just said in the hint. Think about your signs. Negative 3 has to be multiplied by a negative 4 here in order to make positive 12. So when I check this and distribute to check it, negative 3 times x, cool, negative 3 times negative 4 to make positive 12. So you just have to pay attention to this sign a little bit more when you have a negative in the front. Okay, I'll do another one. Negative 8x minus 20. So my factors of negative 8x. Looks like the greatest common factor is going to be 4. So negative, a 2, and a 4, and an x. And then negative 20 is a negative, and a 4, and a 5. So they share that negative 4. Cool. That's my greatest common factor. I've used that. The first term has a 2x left. Second term has a 5. And I just want to check my signs. Negative 4 times a positive 5 is going to give me this negative 20. Okay? All right. Negative 6x plus 3. Okay? A negative, and a 2, and a 3, and an x, and then just a 3. So my common factor would be that 3. But remember, when the first term is negative, I want to pull out a negative 3. Okay? That means I have 2x left for the first term, and just 1 for the second term. Now, check your signs. A negative 3 out front here would have to be multiplied by a negative 1 in order to make that a positive 3. Okay? And the last one, negative 2.5x minus 7.5. Well, negative 2.5 times x, and a negative, and 2.5 times 3. So when I factor that out, the greatest common factor would be the negative 2.5. Okay, coming back to this one. Just got distracted for a long time making this video. So we got our negative 2.5 pulled out. It looks like we have an x left here and a 3 here. And if I check my signs, we should be good with that. Okay. So there's 3 more rows of practice. We've done a lot together, so I think you should be able to do these. I just want to point out, notice again when you see the negatives in front, that means when you pull out your GCF, that's going to be a negative, and then just make sure you check your signs once you get an answer and go back to distribute and check. Okay? So any negatives out front, make sure they can get a little tricky. So I'll let you practice the next 3 rows. Okay, there are, 8, 9, 10, 11 problems there for you to practice. And then we'll come back and check. And then we've got one more thing to go over. So practice these and then we'll check together. Okay, let's check these so far. In the first one I pulled out, my greatest common factor was a 10. And then when I distribute that and check it, looks like it works. Greatest common factor was a 2. I check it by distributing and I get this back again. Good. Greatest common factor here is a 3. Check it with distributing. Yep. Yep. Okay. Second row. Here's where we talked about the negative, right? I have negative 5 as my greatest common factor. So when I distribute, that gives me negative 20x. And when I distribute here, that gives me negative 15. So pay attention to what that sign should be to make sure you get negative 15 back. This one, thinking of factors of 21 and 25, well, 1, 3, 7, 21, factors of 25. So they don't really have a common factor. So this one can't be factored any further. So we'll just say that one's done, can't factor it. And then here, distribute and check. Looks good. Yep. Okay. Careful with this one. Make sure you actually got 16 as the greatest common factor. Some people might have pulled out 2 or 4 or 8, but you need to have the greatest common factor. The biggest thing that goes into both of those is 16. So it's not factored all the way until you pull out the 16. Okay, and the last page here, or the last row, just be really careful. Check these signs in the middle especially, and make sure when you distribute back, it all works. Okay, now you do have a couple more things on the bottom of this page, factoring with fractions. We are going to come back and talk about that together in class. So this is the end of video 4, 3, video 3. End of video 3, you can stop here.